Okay, I'm going to have another look at another vector proof. See how we go here. So look at another vector proof. See how we go here. So OABC is a rhombus. I'm just going to draw that first thing. So we've got a rhombus. OABC is a rhombus, and they are of equal length. Okay, those sides are all length. That's the definition of a rhombus, and OA is parallel to BC as well. So put those things on there as well. Okay, so there's a rhombus. The points P, Q, R, S are the midpoints of sides OA. So essentially that's P, A, B, is R. So it just goes around. So P, Q, R, and S are the midpoints of the sides OA version OC respectively. Prove that that is a rectangle. Okay. I want to show that PQRS is a rectangle. How do I show that? So let's have a think. So what do I want to show? I want to show for that to be a rectangle, then I mean it's more than this, but I would want that PS, the vector PS is perpendicular to the vector SR. So that's the first thing I want to show. I want to show that they're 90-degree angles. And I'd also want to show that PS is perpendicular to QR. Perpendicular to QR. In fact, no, it would be. I would want it to be equal to QR, not just parallel to. I would say PS must be equal to QR because it's a rectangle. It must be the exact same one. And I also want PQ to equal SR. Okay, so they're the things that would be sufficient to show that that's a rectangle. Okay, so I've got our midpoints there. And so let's just write down some vectors now. So let's start with, let's say that this vector here down along the bottom is vector A. And let's say that this vector along here is vector B. And I think that's all we'll define. So we've got those two vectors. And before, what do we know? Okay, so we know, what do we got? We've got, well, the magnitude of A is equal to the magnitude of B. And I always find it helpful that therefore that means that the magnitude of A squared is equal to the magnitude of B squared, which means that A dot A is equal to B dot B. Always comes in handy, that particular property when magnitudes are equal. Okay. Do I know anything else? Magnitude of A is equal to magnitude B. That's it. That's pretty much all we know. So let's get cracking. Let's have a look at what we can do here. So firstly, let's find some of these vectors. So PS first. Let's have a look at PS. Vector PS. I'm starting at P, finishing at S, so it's going to be negative half B plus half A. So there's PS. One thing done. SR is the second thing we want. So SR is equal to half A plus half B. And half A plus half B. Yep, that's correct. Just have to make sure you get all these things right, because otherwise it causes you a lot of problems later on. Yeah, we wanted SR. What else? We wanted QR is going to help us as well. So vector QR is equal to, starting at Q, it's going to be half A Q to R, and then negative half B. Okay. And then the other one we wanted PS, we wanted QR, we wanted SR, PQ, we haven't found yet. That's the last one we wanted. So PQ, sorry about messy writing. PQ is equal to, where's P? So P to Q, so we're going upwards, so that's half B plus half A. Going from P to Q. All right, so now let's have a look at this. We wanted to show, firstly, I think we can do a couple of things pretty quickly. We wanted to show that PS is equal to QR. So here's PS and here's QR, and hopefully, yep, so they are equal to, okay? So you can see that those two are equal to each other. So there's our first tick. Great. We'll write these things down in a second. And also we wanted PQ equal to SR. And so there's SR. and there's PQ. It's just half A plus half A, and they're equal to each other. So straight off the bat, you've got some really easy wins, okay? So what I'm going to write down here is SR is equal to PQ. All right, so I'm just going to put a little tick for myself so that I've proven this, proven that one there. And I also had that's equal to PQ, and then QR, which is equal to PS. Tick. So I've done barely any work, and I've already done 2 out of the 3 of the properties to be able to prove that this is a rectangle. My last one though, I need to show that PS is perpendicular to SR. Okay, so I'm trying to find this last property now. And so let's have a look at how we might do that. So if you're trying to prove that 2 things are perpendicular, what you're trying to do is showing that the dot product is equal to 0. That will give us perpendicular angles. So let's have a look at this and give it a bit more space because I might need it. So here we go. So PS perpendicular to SR. So let's have a look at the dot product of PS dot SR. And we're crossing our fingers and hoping that this thing is equal to 0. So let's do it. So PS, where's PS? PS is negative half B plus half A dot SR, which is, I almost did a negative. It's not, it's just half A plus half B. Sorry that my A looked like a 9 there. That's pretty messy. So let's do this and cross our fingers. It's going to be equal to 0. If it is 0, we're done. So just expanding out that bracket now. So we've got the distributive law that works for us. That's negative 1/4 A dot B. So I've times those first ones together, times the outers together. So I'm just following FOIL here in case you missed that. So FOIL, I've done the first. So now I'm going to multiply the outers together. So that's negative 1/4 B dot B. Great. And then I'm doing my inners together. So that will be plus 1/4, not half, 1/4 A dot A. And then lasts, I'll have plus 1/4 A dot B. So now let's stare at it. I'll just add a bunch of tildes in there. I'll just go through and tilde. Okay, let's have a look at that. Does this thing equal 0? So we have, what have we got? We've got A dot B and A dot B. So I've got negative quarter A dot B and positive a quarter A dot B. So those cancel out. And then we've got this B dot B and A dot A here left over, and we can't cancel that out yet. But remember, we've got this fact up here that A dot A is equal to B dot B. And the reason for that is because the magnitude of A is equal to the magnitude of B. So I'm going to replace this I'm going to replace B dot B with A dot A because we know that they're equal to each other. So A dot A, so it's negative 1/4 A dot A plus 1/4 A dot A. And of course, that's equal to 0. And so therefore, this tells us that PS is perpendicular to SR because we've got 0 for that. They're perpendicular. Therefore, we've shown everything we want to show, and we know that therefore PQRS is a rectangle. Hope that makes sense. That was a fun little proof, but usually they do follow the same sort of path. Really important, write down you want to show first. These are the things that I know that if I show that, then I'll finish the proof. And then write the things down you know. And this little here, I can't sort of stress this enough. This junk up here, if your magnitude of A is equal to the magnitude of B, that means that magnitude of A squared is equal to the magnitude of B squared. That means that A dot A is equal to B dot B, and you'll need that in the proof. Hope that makes sense. Hope you enjoyed the video. See you in the next one.